in the pink guy's frame. But all of a sudden, now there's no force acting on the bubble, but the bubble just starts to wiggle, even though there's no force acting on the bubble. And for the blue guy's bubble, even though the blue guy approached and leave, so his hand should apply some force to his water bubble does not wiggle. So for the pink guy, this thing doesn't make sense. The pink guy does not see that objects getting no force remain at rest, and he did not see that object moving. So the pink guy does not see that his bottle is remain at rest for all time, even though there's no force acting on it. So we know the pink guy is seeing something that does not obey Newton's first law. Therefore, the pink guy is a non-inertial frame, even though we don't know how they are moving relative to other things. So, why does Newton's first law define an inertial frame? They define it in this way. An inertial reference frame is a frame that obeys Newton's first law. If the thing you see in this frame is at rest or moving with constant velocity but no force acting on it, then you are in an inertial reference frame. If you see something that does not obey Newton's first law, if a thing with no force acting on it does not remain at rest, you are in a non-inertial reference frame. That's how Newton's first law defines what is an inertial reference frame, what is not. Any question? Let's look at one more example. This is a video by Ryan Chester. He was a high school student. So he made this video.
Almost everyone has heard of Einstein's special theory of relativity. It was truly groundbreaking. But it doesn't have to be complicated or hard to understand. In fact, I bet we could formulate it ourselves. The theory had two postulates, or parts. The first one said simply that the laws of physics are the same in any inertial reference frame. A reference frame is just what a person considers to be at rest. I say considers because you could also consider it to be in motion relative to something else in the universe. Wow, it sounds like we're developing a theory of relativity. So Einstein said that the laws of physics are identical in any inertial reference frame, meaning one that isn't speeding up or slowing down. But why does the speed have to be constant? Well, that's easy to prove. Just sit in a chair, grab a bowl of popcorn, place it in front of you, sit back, and watch how the laws of physics behave. Nothing's happening. Now let's do the same thing in a car with the windows blacked out. What if the driver decides to change the speed of the car drastically by stopping all of a sudden? All of a sudden, the laws of physics seem to act a bit differently. But if the car travels at a nice constant speed, then the exact same thing happens as when I was just sitting on the earth. Nothing. In both the reference frame of the earth and the car, the popcorn doesn't move. Both the earth and car were moving at different speeds, but as far as I could tell, the laws of physics acted exactly the same. Thus, we can conclude the same thing would have happened in any frame of reference that was also moving at a constant speed, and none of them would have been any less valid than any of the others. So there you have it. We just proved the first postulate. The second...
Okay, I know it's rude for Ryan, but we don't need to learn special relativity in this class, so let me pause that here. So how do we know you are in a inertial reference frame? You just watch a bowl of popcorn. If the popcorn is acting like a popcorn, then you are in an inertial reference frame. But you can see when you are in a car, so if you are in your van big enough, so you can watch the same popcorn in your van, and from your point of view, no force is acting on the popcorn. So according to Newton's first law, the popcorn should remain at rest. But all of a sudden, even though there's no force on the popcorn falls apart, even though force is acting on them. So you know you are in a non-inertial reference frame because what you are seeing does not obey Newton's first law. Okay? Any more questions about the first law? All right. Yes, Olivia.
How does the popcorn move if no force is acting?
Because it is not in an inertial reference frame. You should not talk about physics in this frame. Nothing makes sense in a non-inertial reference frame. Yeah. Good. Any other question? Anyway, if you feel like the things happening around you does not make sense, then it just means that you are in a non-inertial reference frame according to Newton's first law. So if you want to discuss physics, you need to first obey Newton's first law first. You need to go and make sure you are in an inertial reference frame, which everything obeys the first law. That's why the first law defines an inertial reference frame. All right, now let us finally discuss how will a force affect object's motion. Force should be a frame-independent quantity. Everything or everyone should agree on the force you are acting on an object. If I'm in the art, I'm lifting, let's say I'm lifting 100 pounds with single hand, I will be like, yeah, I'm lifting 100 pounds. And my gym pro over here will be like, ooh, Hsing is lifting 100 pounds with single hand. And the other guy in the gym walking by will be like, ooh, that guy is lifting 100 pounds with single hand. No matter who you are, no matter which reference frame you are in, the force you are applying to an object should always be the same. It should be a frame-independent object or a frame-independent quantity. So, a force which is frame-independent can only possibly be related to another frame-independent object. When we look at force, let's say the x component of it, can it be related to your x position? No way. For me, I'll say, I am lifting 100 pounds, so the x position of this dumbbell is 0. But my gym pro will say, hold on, I also see you lifting 100 pounds, but your x position is 1 meter to my right. And the guy walking by will say, no, he's lifting 100 pounds, but his position is back there. None of them will agree on the position they have, but they must agree on the force. So there's no way that force is related to your position. How about x velocity? Will force be related to x velocity? Again, I'm lifting my dumbbell. I am applying 100 pounds to this dumbbell, so the velocity of this dumbbell is 1 meter per second going up. My gym pro will say, oh yeah, it's lifting 100 pounds, so the velocity is 1 meter per second going up. But a guy walking by will say, no, the dumbbell is moving back. It's moving backward with some 2 meter per second velocity. I see the same force, but I do not see the same velocity. Velocity is not frame dependent. there's no way force is related to velocity. So force can no way be related to velocity. Okay? That's why we go to acceleration. That's why we spend 2 lectures and 2 weeks working so hard to go to acceleration. Even though the position and velocity viewed by different frame is different, but when I look at acceleration, I will be like, yeah, I'm lifting 100 pounds, so the acceleration of this dumbbell is 1 meter per second squared going up. In my gym world, we'll agree that, yeah, he is lifting 100 pounds, so the acceleration is 1 meter per second squared going up. And the guy walking by, even though the velocity he sees is different, but the acceleration he sees is the same. He will agree, yeah, that guy is lifting 100 pounds, and the acceleration is 1 meter per second squared going up. So we know that the only possible thing related to force is acceleration. Therefore, we say, aha, if force will affect an object's motion, then it can only affect it in terms of acceleration. The force in the x direction will give you an acceleration in the x direction, and a force in y direction will give you acceleration in the y direction. You know, if you add a force on different object, the result will be different. That's why you put the mass here. If you add a force on this chair, and you try to add the same force on this big table, all right. Yeah, this one is easier to move, and you see the result is different. That's why we know the mass of the object is involved. And the mass of the object is, of course, frame dependent. Everyone will agree the mass of the object is that big. So you have it. The left-hand side is frame dependent, which is force, and the way it can affect motion is by affecting your acceleration, which is also frame dependent. This is Newton's second law. Any question? So what exactly is fx and fy? If your reference frame is like this is x direction, this is y direction, this is your particle, and you apply a force that is going up.